In the expansion of 3x plus 1 to the power of n, the coefficient of the term in x squared is 135n, where n is a positive integer. Find n. Okay, so I know that when I have an expansion, a plus b to the power of n, each term is going to be, and choose a specific p times a to the power of n minus that specific p times b to the power of p, right? And here it's actually going to be a sum, right? So I should have a sum, a sigma here, saying indicating that p changes from 0 all the way to n, and this keeps adding terms that look like this for different values of p. Okay, so I can see that 3x plus 1 to the power of n is going to be 3x plus 1 to the power of n is going to be, and choose, since it's going to be one specific p, I'm going to call that specific pk, okay? A, which is 3x to the power of n minus k, b, which is 1 to the power of k. And I know that for that specific k, this is going to look like 135n x squared. So he's telling me that the exponent for x is 2. And the only thing that gives me x in from these three terms is this one. So I'm going to rewrite this as 3 that is raised to n minus k times x that is also raised to n minus k. And he's saying that this is going to be something. So it's going to be something here. X squared. So I can see that n minus k would have to be 2. So I can say that this is 2. And so is this. Because that's the same exponent, right? Okay, so now I can rewrite this as n, choose, instead of writing k, let's rearrange this. Now I know that n minus 2 is equal to k. So I'm going to have n, choose n minus 2, 3 to the power of 2, x to the power of 2, 1 to the power of k is just 1, I'm not even going to write. And this is equal to 135 n x squared. So I can cancel these x squareds because I don't care about them right now. This is equal to 9. So I'm going to rewrite this as 9. And if I send this dividing, I get that n, choose n minus 2, is equal to 15n. Okay, so we're almost there. How do I find n, choose n minus 2? Well, that's going to be n factorial over n minus 2 factorial, n minus 2 factorial. And he's saying that this is equal to 15n. So this will become what? Well, this is going to become negative n plus 2. So n minus n I'm going to cancel. So this is going to be n factorial over 2 factorial, n minus 2 factorial. And this is still 15n. And this n factorial, I can see that's bigger than n minus 2 factorial. So I'm going to change this into, I'm going to expand this a little bit. So it's going to be n times n minus 1 times n minus 2, and it keeps going such that it's n minus 2 factorial. So I can cancel this with this. So this is going to be n times n minus 1 divided by 2 factorial is just 2 equals to 15n. If I send this multiplying, I get that n times n minus 1 is now 30n. And since n is a positive integer, well, this is going to look like n squared minus n minus 30n equals 0. And this is going to be n squared minus 31n equals 0. And if I factor out n, I get that n times n minus 31 equals 0. Well, from this, I have two possibilities, right? Right over here. From this, I have two possibilities, that either n is equal to 0, which can't be because n is a positive integer, or n minus 31 is equal to 0. N minus 31 is equal to 0, which leads to n being 31.